See how this video goes. So, comparing distributions. This video assumes that you can already make a box and whisker plot and a histogram. So hopefully you guys remember how to do that, although I'll be going over it. The real idea behind this chapter or lesson is that we can sort of make comparisons. So in 811, you compared the results of two different methods of measuring to answer the question, which measuring tool is more precise? Today you'll continue to develop your methods for comparing two distributions of data. So Josh is just starting around a golf. The first hole is 130 yards long. He needs to decide which club to use for the first shot. He has kept careful records about how close his first shots come to the hole, all from the same distance. His records include data from his use of two different clubs, a wedge and an 8-iron over the past year. So obviously just different golf clubs. I went ahead and just went through and put these in order from smallest to biggest. I do not understand why this book insists on not doing that for us. It's so much extra work and such a pain and just an opportunity to make mistakes, but hopefully I didn't. So anyways, create a histogram and a box plot for each of the diagrams. It does give us an E tool to do it, but I'm just going to do a little scratch one down here. Like I said, the assumption in this chapter is that we can do it. It's just the discussions of what they look like. By the way, just to kind of go into the math notes real quick, this is what they would look like if you had done them in a calculator, which you will for sure in high school, if not earlier. Although I think probably in high school, you'll use the TI-84 to do that. You can see the histograms down here, and this is the box and whisker plot, and they lay on top of each other. And I think we kind of talked about this a little bit, but this is like if you imagine this being a roller coaster. So like this would be a roller coaster that you look at from the side, and then this would be the roller coaster that you look at from the top. And remember, we have those quartiles, so this is 25%, this is 25%, this is 25%, and that's 25%. And you can see if you look at it from the side, that makes sense because a lot of that roller coaster is right there in the middle. However, it kind of stretches on the side and it kind of stretches on this side. So you can see, again, over here on this one, you can see a lot of this roller coaster happens from here to here, and then it just sort of stretches out in this direction. So again, I hope that makes sense to you, that we're sort of looking at the side of a roller coaster when we're looking at a histogram and the top of a roller coaster, and you can almost see that curve up on the top. Mine won't look this good, but that's what they should look like if they look good. So we're going to create a histogram and a box plot for each set of clubs, and we're going to place the box plot above the histogram on the same number line for each club to make a combination plot. Use a bin width of 5. So essentially I'm just going to go 0 to 5 to 10 to 15 to 20 to 25. It looks like 25 is as far as I'm going to go. Although we'll talk about it why I need to, but I actually need to go to 30. So on this one, we're going to go by 5. So anything from 0 to 4 is going to fit in the first one. And I hope this makes sense to you, that this is where the breaks are at 0, 5, and 10. So I can't go from 0 to 5. Otherwise, I'd be putting 6 numbers in, like 0, 1, 2, 3, 4, and 5. That adds up to 6. I actually need to go 0, 1, 2, 3, and 4. So I have 1, 2, 3, 4, 5 numbers here. So, I don't know. I'll just say 1, 2, 3, 4, 5. And we'll say that this bin has 5 in it. Then from 5 to 10, I actually have 2. I have 5, 6, 7, 8, and 9. So there's 2 of them there. So we'll go from 2 there. And then from 10 to 14, 10, 11, 12, 13, 14, I don't have any. And then 15, 16, 17, 18, 19, I have 1. Again, I hope you guys see why I'm doing that. Again, they fall in this direction, right? 0 falls in here. 5 falls in here, 10 falls in there, 15 falls in there, 20 falls in there. So 20 to 21, I have 1. And this is why I had to actually put that last one here. 25 is going to fall between 25 and 30. It's not going to fall between 20 and 25. So when I go up here, I'm now going to make my box and whisker plot. I know I have the smallest one is at 0. and my biggest one is at 25. If I start working my way in, actually, I guess I should count first one. Well, I guess I don't need to count because I'm doing it this way. So there's 4. So it looks like the split, I have 1, 2, 3, 4, 5 on the left, 1, 2, 3, 4, 5 on the right. So I need to get the middle of that, which would be 4. Hopefully you know the average between 3 and 5 is 4. And then I didn't cross any numbers out, so I'm just going to go with 2 there, then cross out 2. So this is my quartile 1 is at 2. And then over here, it's going to be at 15. So I'm going to go here at 15. I will go ahead and do my box and whisker plot. So that would be the one for the wedge. I can see I did not leave myself a lot of room for the 9 or the 8 iron, so we'll go 8 iron, and again I'm just going to go 0 to 5 to 10 to 15 to 20. This one, it looks like I only need to go to 25 though, which is nice. So I have 0, 1, 2, 3, 4, so I have 1 on this one. Again, I should probably say 0, 1, 2, 3, 4, 5. 5, 6, 2, 3, so I have 4 here from 5 to 9. That looks terrible. 10, 2, 3, 4, 5, 6, 7. So I have 7 on this one from 10 to 15. And then I have, it looks like just 1 and 1, right? 15 to 19, I have 1. And then 20 to 25, I have just 1. I'm actually going to have to erase my title because it's going to be in the way here. So I will rewrite it. So again, pretty rough looking, but hopefully you're following what's going on there. When I do my box and whisker plots here, again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data. So between 7 and 8 will be my median at 10.5, so I'll go a little bit past 10 and I'll put my 10.5. Obviously my lowest is at 3 and my largest is at 20. And then for my quartile 1, I have 1, 2, 3, 4, 5, 6, 7. So it'll be the 4th number, which is 8. And then 1, 2, 3, 4th number will be 12. So there we go. There's my box and whisker plots and my histograms on top of it. And now, in theory, what I could do is I could go down here, just like they have here, and I can make a comparison. Although I didn't draw mine parallel, they didn't ask me to. Mine's more like this, where I'm kind of comparing across from each other. So it says to find the typical distance that Josh hits the ball from the hole with the wedge. Is the mean or the median a better choice? I would definitely say the median. Remember we said if it's skewed in one direction, we don't want to use the mean. It's kind of like Bill Gates. If Bill Gates walked into our classroom and we took the average, everyone would appear to be rich. But if we took the median, it would give us a more realistic thing. So if our data is skewed, we want to do the median. So I would say on this one, we want to do the median. Find the typical distance Josh hits the ball from the hole with the wedge and compare it to the typical distance he hits it from with the 8 iron. Well, on this one we said it ended up being like 4 was our median, and on this one I think we said it was 10.5, right? That was our median because it was between 10 and 11. So he typically hits it closer with the wedge. Now, advise Josh which club to use. Explain your thinking. I mean, I guess it's easy to say that he should use the wedge because typically, 50% of his shots are closer, but that's not necessarily looking at it all together. he's definitely more consistent with the 8-iron, so that could come into play as well. But I guess for now, we'll just say the wedge and then go from there. I think what's going to happen is the book's going to lead us to saying, hey, the wedge is better here, but then if we consider other things, the 8-iron is better, and then you're sort of situational. So let's keep going. So it says, it is just as important to consider the spread of the data as it is closer to the center when comparing the data sets. So we only looked at the center here when we said the wedge was better. So calculate the interquartile range for each golf club in the previous problem, with which club is Josh more consistent. So on this one we went from 2 to 15. So his interquartile range was 13 on the wedge, and the interquartile range over here went from, it looks like 8 to 12, so the interquartile range was only 4. So if you think about that, he's a lot more consistent with the 8-iron than he is with the wedge. So if he wants to go for broke and hit it close, he should use the wedge. If he wants to be consistent and have a pretty good guess how far he's going to be and not be in terrible shape, he should probably go with the 8-iron. So if Josh decided to use the 8-iron, he could typically expect the ball so that it lands between 8 and 12 yards from the hole. This is indicated by the box on the box plot display and corresponds with the IQR. If Josh decides to use the wedge, what is a typical interval of distances? Well, we would say he would expect to be between, it looks like, 2 and 15 yards, right? So definitely a little bit further out. And then it says compare the typical interval of distances to the 8-iron with what you found for the wedge. So, here he's between 2 and 15 yards out, his middle 2 quartiles, and over here he's between 8 and 12, so a little bit consistently. If he's a great putter, 8 to 12, whatever. I don't really want to turn this into a conversation about golf. I just hope that you see, if we look at the median, the wedge is better, but if we look at the spread, the 8-iron all of a sudden comes into play as an option. So, 821, it says Mr. Webb has only one more starting position available on his basketball team, but 2 students have tried out for it. He wants to choose the student who is likely to score the most points. So the 2 students from whom he can choose are described below. So in her most recent games, Jana scored this many points, while Alana scored this many points. Again, I already put them in order from smallest to biggest. Which girl has the highest average? Well, if we're going to use the average, I'm definitely going to use a calculator on this. So we will say it's 6, 13, 20... 27, 34, 43, 52, 61, 70, 81, 92, 103, 114, and then I'll just start adding with a calculator for the rest. Plus 19, plus 46, plus 55. I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I counted that wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I divided by 16. And I appear to be getting, that's disappointing. 234 divided by 16. I get 14.625. And then on this one I get 19, 22, 35, 45, 50, 65, plus 34, plus 18. So we'll divide 117 by 1, 2, 3, 4, 5, 6, 7, 8. And we will get 14.625. So they both have the same median. The same mean. They both have the same mean. But obviously, if you're looking at this data, there's quite a few differences. So they both have a 14.625 mean. Which student do you think Mr. Webb should select and why? Use a parallel box plot, 2 box plots on the same number line to support your explanation. So what we'll do is we'll just go ahead with a, I guess we don't really even need to, we'll just say 0, 5, 10, 15, 20, 25, 30, 35. Trying to keep these roughly the same size. They should be roughly the same size. Obviously, they're not exact, but they're not bad. Okay, so Jana, we'll put Jana on bottom. Her lowest is 6. Her highest is 55. you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So between 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we're going to say her median is 9. And then we're going to say her quartile 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say between the 4th and 5th number. So we're at about 7. So these are pretty tightly packed together. Hopefully you're kind of seeing where they're going with this. We will see. And then over here we have to go, it looks like between 11 and 19. So I think we're looking at 15. So we get something that looks like that for Jana. Now if we go to Alejandra, we'll put Alejandra above her. Her lowest is 9. Then we'll go to 18 for the highest. And then we'll go for the middle. You can see halfway is between 15 and 15, so our middle's 15. And we will say that her quartile 1 is 13 here. Oh, I didn't mean to do that. And then here we'll say it's 17. So which player would you say he should choose? Well, I guess the argument would be this is 75% of her games. 75% of her games is higher than over half her games, right? So Alejandra is way, way, way more consistent than I suspect they made an error on this too, by the way. I'm not sure than Jana is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 there, then 7 and 6 and 2, 3, 4. Oh yeah, okay, so this should have been here. So I apologize. That actually should have been an 11. So my mistake. Not going to recut all that though, I'll tell you that much. So this one actually should have been like this. So you can see 75% of her games were above 25% of her games. So, you know, depends on what you want to go for. If you need someone to just go bonkers and go absolutely insane and go Jordan on them, then I guess you would take Jana. But if you just want some consistently decent points, then I think Alejandra is the one you want to go with. Why was the mean not a good measure of Jana's? I would say the mean's terrible because she's had a couple high games. She's sort of like that Bill Gates thing, right? She got a couple of super high scores right here, but it definitely impacts the rest of them. Calculate the IQR. Again, we have the difference between 7 and 11, so her IQR is only 4. Her IQR is also only 4. Just the range is better for Alejandra. She's got a higher one than there. And then who has the higher median and how many points? We would definitely say Alejandra has the higher median. She has 15 compared to 9. So you would expect her to score 6 points more typically. All right. And then 822, we have another box and whisker plot. Honestly, I don't know if I have this in me. They want us to put these together again, so let's just see if we can do this quickly. So 20, 30, 40, 50, 60, 70, 80, and I will say Greg, his lowest is 40 and his highest is 73. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So should be 7 on each side. 1, 2, 3, 4, 5, 6, 7. So it's going to be halfway between 55 and 59. So it looks like we're looking at a median of 57. And then from here we have 1, 2, 3, 4, 5, 6, 7. So it'll be the fourth number, which would be 51. So we'll go over here and we'll say 51, and then the fourth number, 1, 2, 3, 4, it looks like 68. So we have Greg's box and whisker plot. And then we will go with the sister. Again, 37 is her lowest. So we'll say this is the sister. 64 is the largest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 7 on each side. 1, 2, 3, 4, 5, 6, 7. So it looks like we're going to have a median of 49.5. And then 1, 2, 3, 4. We're going to have a quartile 1 of 42. And we're going to have a quartile 1, 1, 2, 3, 4 of 57. And now we can kind of make some comparisons with these two. And it is asking us, okay, Greg and his sister shared a computer at home. In order to be fair, they kept track of how much time they spent socializing with friends each day. The last 2 weeks, their usage in minutes as follows. So make a parallel box plot to compare their usage. Is their median usage notably different? 57 versus 49. I guess you can make the argument it's 8 minutes difference. I don't know if it's that big of a deal or not. We could say the interquartile range, his interquartile range is 17. Her interquartile range is 15. So that's pretty standard. So, I don't know. Obviously Greg's using it more. He's got a little bit more variance. I guess he depends on how good his siblings they are, if you think that's a big deal or not, from there. It's that point, I want to show you guys' assignment. We are going to look at something like this, and there's 18 problems. I don't expect you to finish the whole thing. The further you get, the more it'll be worth. Just go in order. You have the data. You need to put these in order from smallest to biggest. But the minimum, the maximum, the median, quartile 1, quartile 3, and then just match it up with what goes with it. Same kind of a thing here. Here, you're answering some questions about the box plot. On this one, you are actually going to have to figure out the frequency distribution, like how many numbers occur between 70 and 74. So there's 1, 2, 3, 4, 5, 6, 7. So it looks like 7 of them. So if I would submit that, you can see I got that part of it right. You just have to get the rest of them right and then figure out what the histogram would look like. I would say you definitely need to get through at least question 6 on this. If you get through question 6, that's what everything. And then if you get past that, that would be extra credit. Again, here you're just going to put these in order and tell me what they are. Should be pretty simple. This just means that there was 4 bits of data at 25 and 5 bits of data at 27 and 3 bits of data at 28. So you can actually even write that out if you want to figure out what the median is and what the lowest number is. But obviously the lowest number should be 25 and the biggest number should be 34. So, at that point, I think this one eliminates everything. And, may you get that lucky on yours. If you keep going, there just recycles these questions. Like I said, the first 6 is going to be the homework. Beyond that will be extra credit. We will wrap all this up on Tuesday, and please be good for the sub.